So today's lesson is going to be about counting elements in a set. We're going to do a continuation of what we talked about yesterday with Venn diagrams, and we're going to actually use them to perform some math and figure out some different things about unions, intersections, and such. So let's define some more vocabulary. First of all, a Venn diagram is simply used to represent sets of things, and each set goes in its own circle. Any overlap is in that space where the two circles overlap in between them. The universal set is the set of all of the things that are being considered. So a universe can be everything in the universe, or a universe can be, I don't know, like people in the school. And then we're going to break that down into classes. Or the universe could be people in a specific city or things that I have in my closet, whatever. So you can kind of define what the universe is, and that's all the things you're looking at, and then we're going to place them into different groups, okay? The complement is all of the elements in the universe that are not in the set given. So for example, the complement of A would be written A apostrophe, and that means everything that is not in A. Everything that's in the universe that is not part of set A, okay? We'll talk about complement a little bit more so you get kind of familiar with it. So here's a Venn diagram. This is kind of an interesting one. We've got a set of things I have in my house. We have a set of things I know how to use, and we have a set of things that can be used to kill zombies. Our universe is in the box, and notice I have a couple of things outside that don't belong to any sets. For example, a horse. I do not have a horse in my house. I don't really know how to use one, and I don't think you can use a horse to kill a zombie. Okay, same with a rotary phone or a particle accelerator. Feel free to debate that amongst yourselves, but we're going to go with those three things being in the universe but not fitting into any of those sets right now, okay? So notice that there's a little bit of overlap. For example, I have a cell phone in my house and it's something I know how to use. However, it is not included in things that can be used to kill a zombie. I don't know that we could use a cell phone to kill a zombie, okay? Notice there's one thing that fits all three. I have a baseball bat in my house. I know how to use it, and I could definitely kill a zombie with it, okay? And then you can kind of see the other things. So let's talk about what this looks like. For example, we're going to take the B union C, and then we've got that little apostrophe, which means the complement. So what this means is we're going to take all of the things or all of the elements that are not in B and C together. So not in B and C together, okay? So we're looking for all the things that are not in the yellow and blue together. That would be all of these things out here, okay? So guinea pig, Galileo thermometer, washing machine, etc. And we're just going to list them all out in a set. And again, notice I've abbreviated a couple. That's okay. That's fine. What I didn't include, what I forgot to include in my set, and I should have, is also, if I can write it here, horse, rotary phone, and the particle accelerator should also be included in there. And I forgot to put those in because those are in the universe, but they are not in the grouping or the union of B and C, okay? So this little apostrophe is kind of important because it means a lot of things. It means all the stuff that is not included in whatever's in front of that. In this case, the union of B and C. Now, the second one is a little different. What this means is that we're taking the set of A, all right, and we're going to combine it with all the things that are not in C. So this one is a little bit different because this apostrophe applies just to the C, not to the whole thing. And you'll see that the parentheses are what make that different, okay? So we're going to take all the things in A, which is that entire red circle, and then we're going to add to that all the things that are not in C. So that's all of these things out here. And then, of course, including the horse, the rotary phone, and the particle accelerator. And we're just going to list all those out as a set again. Again, you can abbreviate or whatever else, and we can look at it that way. Now, again, I forgot the horse, the phone, and the particle accelerator. So make sure that those are included when you write this out, okay? I hope we're kind of getting the idea here. Let's do a couple more. So remember that this upside down U, if you will, is the symbol for intersection. So what this is asking is the intersection of A and B and C. So what is the one thing that is in all three of those where they intersect? That would be just the baseball bat. That's the only thing that's in the intersection of all three of them. Okay. This next one is the complement of A. And what that means is all the stuff that is not in A. So basically anything that's not included in that red circle, we're going to list out. Okay. And this is a long list. It sure is. That's okay. We're just going to list out all the things that are not in the red circle. So anything in the yellow circle, but remember that the cell phone, the George Foreman grill, the baseball bat, all those things are included in the red circle, so they're not included in the complement of A. All right, that one was kind of fun, just interesting to look at. Let's try another one. This one's going to be a little more, little simpler, I think. We have fewer elements here. So the universe is the letters of the English alphabet, A through Z. Set A is A through M, and set B is just the vowels. So let's start by creating a Venn diagram. So what I'd like you to do is pause the video for a second. You have the two circles here. See if you can fill them in correctly, okay? Hopefully your Venn diagram looks like this. You've got set A, set B, and then the crossover between A and B is A, E, and I. And then remember, in our universe, also included are the letters that are not in either of those sets. We put them outside the circle. So that's why the X, Y, Z, V, W, S, T, R, P, Q, and N are outside those circles because they're part of the universe. They're part of the alphabet, but they're not contained in either set A or set B. So now that we've got our Venn diagram, and if you didn't quite get it, go ahead and fix. Now we want to look at some of the notation. So we're going to first look at the union of A and B. That means we're taking A, we're combining it with B, and we're just going to list out all the things. That's everything that's in these two circles, okay? So we're going to list out all of the letters contained in the two circles, and we're just going to list them using our squiggly brackets for set notation. All right, notice we're just not including any of the things outside of the circles. The next one is the complement of A. So what this means is anything that is not in set A. So we're going to list everything that is not O, A, E, I, and U. Okay? So all of the rest of the letters are going to be listed out here, and we're going to, again, write those in the brackets using our set notation. I hope you're starting to kind of see how the complement works. The complement is simply the not, the opposite, what's not in the set that I just gave you. Okay? This next one is looking for the intersection of A and all the things not in B. So what is the intersection of A and all the things that are not in B? Well, all the things not in B is everything except for these. So I'm going to cross these out. Okay? Now the intersection of those two would simply be O and U, because O and U are both not in B and also in A. That's what the intersection means. That one's kind of that's a little difficult. You kind of have to think about that one a little bit. That one's a thinker, okay? But I hope that makes sense to you. The intersection of A and then what's not in B is simply O and U. Now, this next one is talking about the union, so the combination of what's not in A and what's not in B. So the combination of what's not in A and not in B would be all of these things outside of A and B. So that would be the NPQ, RTS, VW, XYZ. And we're just going to list those out again in the brackets, okay? Are you kind of starting to see how this is working and how we're kind of setting up the Venn diagrams, but then also figuring out the intersections, the unions, and then the complements? Let's try another one. So again, pause the video and see if you can put these in the right spots. It doesn't really matter how you label your circles. I chose to go with L on the top and then M on the left and N on the bottom. Doesn't matter. But go ahead and pause the video and put these sets into the Venn diagrams and see how you do. Hopefully it looks like this. Hopefully you got all the pieces in the right spot. Notice there's no crossover between L and N or L and M. And 6 is the only crossover between M and N. So that's why this Venn diagram kind of looks like this, okay? So we're going to do a couple of different things with this. Notice that also there's a 10 outside, okay? Because our universe is 0 through 10, and 10 is not listed in any of these sets. So we have to include that in the universe, but not in any of the sets. So now that you have that written down and hopefully correct, let's do a couple of sets here. So we're looking for the union of L and M. Which numbers are in L and M when we put them together? That would be 1, 2, 4, 5, 6, 7, 8. So almost all of them, but not quite. Okay? This is the intersection of M and N. What do they have in common? 6 is it. That's the only thing they have in common. The union of L and N. So we're going to take L, we're going to take N, and we're going to put them together. We get 0, 1, 3, 5, 6, 7, 9. And then the complement of N. So anything that is not included in N. 1, 2, 4, 5, 7, 8. And don't forget the 10, because 10 is in the universe and it's not included in N. So that's part of the complement as well. Hopefully you're kind of understanding this. Let's do one that's a little more interesting maybe. We've got this here, okay? This is a Venn diagram, even though there's only one. And notice that placing the letter N in front of a set is asking you to tell the number of things or number of elements that are in that set. For example, when I'm saying NA, what I'm asking is how many things are in set A? Well, there's 1, 2, 3. There are 3 things in set A. So now we're not listing them out anymore. The N means just tell me how many there are. You don't have to list them all. We're just going to say how many there are, okay? So let's try this. The number of things in the universe. Well, if you count up everything in this box, there are how many letters? There are 26, right? Now the question is how many things are in A? Well, if we count them all up, we're counting the purple and the orange letters this time because they're all in A. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of them. So we have 13 things that are in A. This next one is asking the number of things in the complement of B. So how many things are not in B? Well, again, we're going to count them up. B only contains 5 things, right? So we're going to count up how many there are. Or if you don't feel like counting, you could take 26 minus 5 and you would get the answer of 21 things are not in B. So this one's a little different in that you're counting up how many things instead of listing them all out. But the rules still apply, okay? So this is a universe here. We could call it whatever we want to. Animals, I don't know. But the question is, how many things are in the universe? Well, how many things are we looking at? We're looking at 9 things here. So the number of things in the universe would be 9. How many things are in W? What do you think W stands for? Probably wings, right? So how many things are in the wings category or having wings? That would be 6. There are 6 things in that category. How many things are in the intersection of W and E? Well, if we look at the intersection here, we're looking in this middle. What do they share? They share 3 things. There are 3 things in that intersection, okay? Hopefully this is kind of starting to make sense for you. Take a look at this next one and kind of pause the video, see if you can answer the questions, and then start it back up and see where you're at. Okay, so hopefully you came up with the number of things in the universe is 13, and that the number of things not in B is 4, and the number of things so in the complement of the intersection. So we're going to take the intersection out and we'll count how many of the other things there are, and there are 9. 4 in the dark blue and 5 in the super light blue, and that makes 9 total. Okay? Now, sometimes it can be a little tedious to count all the elements depending on how big the universe is. So what have we noticed about Venn diagrams? If you kind of think back to that alphabet one, remember I didn't want to count them all up. If I know there's 26 total, I can just subtract how many are in the set, and then I know the answer to the complement or whatever else, okay? The union we can do by adding them up. And then we want to take out any repeated elements. The intersection is simply how many are repeated. So we're going to break down a Venn diagram here, and we're going to kind of put the pieces all together and see what we can come up with, okay? So a sociology class surveyed 1,100 students about which meals they ate in the cafeteria and found the following information listed out in this table here. Now, I want you to catch the important piece here. We're talking about 1,100 students, which means that the universe has 1,100 students. Not all of them may be in the categories, okay? So just kind of know this. So let's start by labeling our circles. We're talking about 3 meals here, right? So we've got breakfast, lunch, and dinner. So let's call 1B, 1L, and I'm going to put B here, L here, and then D for dinner over here, okay? And then we're going to kind of work through the categories and see how many are in each one. So starting with how many ate all 3 meals? 240, meaning that the intersection of all 3 has 240 people in it, okay? That's the easy one. Now we know 375 ate breakfast and dinner. But 375 means that that's the intersection of breakfast and dinner. That includes the 240 that we've already accounted for. So we need to subtract 375 minus 240, which means there's 135 people who ate just breakfast and dinner, but not lunch. Okay, does that make sense? Because we've already accounted for 240 people who ate 3. So of the people who ate breakfast and dinner, 240 of them also ate lunch, which means that there's 135 who only ate breakfast and dinner. The same works for the lunch and dinner. So we have 505, but we need to subtract the 240 that are already accounted for, and that gives us a total of 265 ate lunch and dinner. So I'm going to put that in this intersection. I'm going to try between lunch and dinner, okay? 265. And then 275 ate breakfast and lunch, but we have to subtract the 240, which means that there are 35 people who ate just breakfast and lunch, but not dinner, okay? So hopefully you're kind of seeing how that works. Now let's look at these last 3 here. We have 855 who ate dinner. But of those 855, 135 of them ate breakfast and lunch, 240 of them ate all 3, and 265 ate lunch and dinner. So we're going to have to subtract. So we're going to take 855 minus 265 minus 240 minus 135, and we come up with a total of 215 people who ate just dinner. Okay? Go ahead and do the same thing for lunch and breakfast. So we're going to subtract all of the pieces that are in the middle. And so for lunch, I got 140. And then for breakfast, I got, let's see, 15. Okay, go ahead and check my math. Make sure that I'm correct on that. Make sure that I got all the numbers right. Now, let's think about the universe, because there were 1,100 students total that were asked. Do all these numbers add up to 1,100, or do we have some people who didn't eat anything? So let's add up. Let's see, 15 plus 35 plus 240 plus 135 plus 140 plus 265 plus 215, and we get 1045, meaning that there are 55 people out here. If I do 1,100 minus 1045, I get 55 people who didn't eat any meals in the cafeteria. Okay? So now that you have this Venn diagram, you can go through and you can answer some questions. Go ahead and answer these. You can just answer these on your own using the information from the Venn diagram there. And you should be able to kind of just add up the numbers. Okay? Hopefully you kind of understand how this works. It really helps to sketch out that Venn diagram, fill in the numbers. Make sure you're subtracting as you go so that you get the total number of people in each sort of section of the Venn diagram. Okay? We'll do a little bit of practice with this on your assignment, and then we will continue on with set stuff tomorrow.